Alright, so today I'm going to be going over this problem which has been requested by a few of my students just because it is a very, very difficult SAT problem. So we're told that in this figure we have a length AD and that length is 121 over 3. So that will be this length here. And then we have a length AB and that's 11 times the square root of 130 divided by 3. So that is this length right here. Now it's important to notice, right, we have this larger triangle and then it's comprised of those two smaller triangles. So the first thing I'm going to do is I'm going to draw out that largest triangle, the triangle ABC. So I'm going to draw that out now. And then, if I look at this here, right, we have B as our right angle. So this right angle here is B. And then, on our top, we have angle A. And then on our other corner here, we have angle C. So triangle ABC. And then I'm going to draw out the medium triangle here, which is this triangle here, and this triangle ABD. And I'm going to draw that out in a similar way here, right? Except in this case, D is our right angle. And then on our top, we also have A. So this is A. And then on our other side, we have B, right? But it's not the same B as the other triangle. It's just kind of cropped off a little bit. So that corner is going to be B. So we've drawn out those two triangles here. And one thing we can kind of notice right from the get-go is that we have a common angle here, right? They both have angle A. So we can say that angle A is equivalent to angle A, right? Because again, it's just the same angle, just in two different triangles. So our next step here is to kind of, find out what those missing angles could be, right? So for this triangle here, for the first one, we know that angle A plus angle B plus angle C, we know these all have to add up to 180, right? Just our simple triangle angle rules. So I'm just going to fill in what I know. So I know angle B is 90 degrees, right? So I know that A plus 90 plus C is equal to 180. And then I'll subtract 90 from both sides, and I get A plus C is equal to 90. And then for the other triangle, kind of the same thing, right? We know that A plus D plus B. Remember, the B angle in this triangle is different than the B angle in the first triangle. And we know that all these angles, again, add up to 180. So then just, doing some simple math here, we know that angle A plus 90 plus B is equal to 180. And then just subtracting 90 from both sides, I know that A plus B is equal to 90. Now we see here that A plus C is equal to 90 and A plus B is equal to 90. And since A is equal to A in these two triangles, right? So this A is equal to this A. I can just say, and both of these equations are also equal to 90. So actually I'll go back a little bit here and start with just, since both of these angles are equal to, or both of these, equations are equal to 90, I can use substitution here and I can say, okay, A plus B is equal to A plus C, right? Because they're both equal to 90. So A plus B is equal to A plus C. And then just subtracting A from both sides, again, because they're the same angle, I can say that, okay, angle B is equal to angle C. So that means this angle here is equivalent to this angle here, which makes sense, right? Because we know that if two angles of two triangles are the same, that third angle has to be the same as well. So what we have here now is a pair of similar triangles, and this is going to help us a lot because the rule is with similar triangles is that the ratios of their sides with each other are the same. So I'm told here in my information, right, that AD is equal to 121 over 3. So this side here is 121 divided by 3. And then AB is 11 times the square root of 130 divided by 3, right? So now I can make an equation, and again, my simple similar triangle rules, I know that the ratio of the hypotenuse of this triangle, so that's AC, and then divided by AB, which is this side length here, I know that that ratio is going to be equal to the ratio of this hypotenuse, which is AB, and remember AB here is also 11 times the square root of 130 over 3. I know that that is going to be equal to that hypotenuse, so AB, divided by AC. Or sorry, not AC, AD. right? Because again, it's the hypotenuse divided by this side right here. So that's going to be AB divided by AD. And then what I can do is I can just multiply both sides by AB, and I get AC is equal to AB squared over AD. And then I'm just going to use the bottom here to do the rest of the problem. So then I'm going to plug in my numbers, right? So I know that AC is equal to 11 times the square root of 130 over 3, right? Because that's the side AB, and that's squared. And then divided by AD. And again, AD is equal to 121 divided by 3. So from that, if I put that into my calculator, I know that this is going to be equal to 43.33, or 43 and 1/3 basically. So then, now that I know what AC is, right, and AC, remember, is this entire length here. So if that entire length there is AC, I know that AC is going to be equal to AD, right, which is the shorter one, plus DC. So AD plus DC, right? And then I can just fill in the blanks here, right? So I know that AC is 43.33, so 43.33, and that's equal to AD, and AD is 121 over 3, plus DC. And kind of can't really fit that in at the end, but that's DC at the end. So then all I need to do here is subtract 121 divided by 3 from both sides here, right? And if I do that, I get 3 is equal to DC, or DC is equal to 3. Now I know this was a very complicated problem, so please let me know in the comment section if you do have any questions, and I will do my best to answer all of those. And as always, my email and my link for 101 tutoring is in the video description.